Good morning, students. Today you will be learning the rule of negative exponents. This will require a review of other exponent rules that you have learned in the last week. And you will be able to apply the negative exponent rule to write expressions containing only positive exponents by the end of this lesson. You will also get practice applying previously learned exponent rules to simplify expressions. Let's get into it. To start, let's review the zero rule you learned last week. In the zero rule, we know that any number divided by the same number is equal to 1. And therefore, if we have an exponent divided by an exponent and both bases are the same, the answer must also be 1. For example, x to the second power divided by x to the second power equals 1. Considering the quotients property that you learned, when we divide numbers with the same base, we can just subtract the exponents. So in the case of x to the second power divided by x to the second power, we can apply that quotient property and it will be x to the second power minus the second power, which would equal x to the 0 power. And we already know that x to the second power divided by x to the second power must equal 1. So therefore, x to the 0 power must also equal 1. Simplified, the zero rule states that any non-zero number raised to the 0 power is equal to 1. If we have 0 to the 0 power, it is equal to undefined, and this is because we cannot divide by 0. Negative exponents. As exponents decrease by 1, the value of the powers are cut in half. We know that 2 to the 0 power must equal 1. So that means that 2 to the negative 1 power, which is decreased by 1, must be equal to 1/2. And 2 to the negative 2 power must equal 1/4, which is half of 1/2. 1/4 also happens to be equal to 1 over 2 to the second power. And from this pattern, the following negative exponent rule is derived. For any non-zero number, z, and any integer n, z to the negative n power is equal to 1 as the numerator over a denominator of z to the n. All right. So let's get some practice writing expressions using only positive exponents. And we'll start with this expression here. It's 16x to the negative 6th power times y. Now what I'm going to do before I move any further is I'm going to separate out the coefficient and the exponent and the other variables. And I do this just because it makes it a little bit clearer what is negative and what isn't. So in this case we have 16 times and then x to the negative 6th times y, and that y by itself is y to the power of 1. Now, it's really easy for me to see that what I need to do is apply the negative exponent rule to x to the negative 6th. And our rule states that we can rewrite that exponent using just positive exponents if it is written as the denominator under 1. So now our new line is going to be 16 times 1 over x to the 6th power times y. Now 16 is positive and y is positive, so when I rewrite this using only positive exponents, it will look like 16y over x to the 6th power. All right, let's do another one. And this one is actually number 3 on your worksheet, if you have your worksheet out. It's number 3. And the expression is 3y to the negative 2nd power. So in this case, I'm going to separate out the coefficients from the variables. It's 3 times y to the negative 2nd. And now I just apply my negative exponent rule. It's going to be 3 times 1 over y to the 2nd power, or y squared. So when I rewrite this, it's going to look like 3 on the top and y squared, or y to the 2nd power, is the denominator. Let's take a look at another one. In this case, we're going to be rewriting this expression without a fraction bar. So to start, it is 1/16. And I'm first going to write this as the product of prime factors. So it's going to be equal to 1 over 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And then I'm going to rewrite that using exponents. So that'll be 1 over 2 to the 4th power. Now we can just reverse our negative exponent rule and rewrite this as 2 to the negative 4th power. Oops, let me rewrite that 2 to the negative 4th power. No fraction bar. This next one is number 7 on your worksheet, if you have that out handy. And again, we're going to write it without a fraction bar. So the original expression is 2 over a to the 8th power. I know that the 2 is positive, and if I apply the negative exponent rule, since a to the 8th power is in the denominator, I can rewrite that as a to the negative 8th. On this next set of problems, we need to find the product or the quotient and only use positive exponents. So if we're looking at 3 to the 8th power times 3 to the negative 10th power, the very first thing we want to do is apply our products of powers property. And that states that any base number, if the base numbers are the same and you're multiplying them, then you just add your exponents. So we'll do that. So 3 to the 8th power times 3 to the negative 10th power is the same as saying 3 to the 8 plus negative 10 power. Well, what is 8 plus negative 10? Yep, it is negative 2. So 3 to the negative 2 power. And now, since we have to write this using only positive exponents, we'll apply our negative exponent rule, and this is going to be rewritten as 1 over 3 to the 2nd power. Okay, this next problem is actually number 10 on your worksheet. So we will have 5 to the negative 8th power times 5 to the negative 7th power. Again, we're going to apply our product of powers property, and that's going to become 5 negative 8 plus negative 7th power. So now we'll add our negative 8 and our negative 7, and that gives us negative 15. So we have 5 to the negative 15th power. Then we'll apply our negative exponents property, and it will become 1 over 5 to the 15th power. Now let's look at 8 n to the negative 3rd power over n to the 2nd power. So in this case, I'm going to be applying the quotient of powers property first. So I'm going to take my 8 out, the term 8, and that's going to be 8 times n to the negative 3 minus 2 power. Negative 3 minus 2 is negative 5, so now I'm going to rewrite this as 8 n to the negative 5th power. And then since I can only use positive exponents, the 8 is positive, so it's going to be part of the numerator, and the denominator will be n to the 5th power. This next expression is number 14 on your worksheet. It's 7 squared over 7 to the negative 8th power. So first we'll apply our quotient of powers property. So that's going to say 7 to the 2 minus negative 8 power. 2 minus negative 8 is the same as saying 2 plus 8, if you recall from when we learned about integers. That would be 7 to the 10th power. This next expression is number 18 on your worksheet. It is 8z to the 6th power d to the 5th power over 7z d to the 2nd power. So first I'm going to separate out my coefficients and my exponents. So it's going to leave me with 8/7 times z to the 6th over z which is the same as saying z to the first power, times d to the fifth over d squared, or d to the second power. Now I can apply my quotient of powers property to the exponents. Still have 8/7 over here. It's going to be multiplied by a z with 6 minus 1 as the exponent times d with 5 minus 2 as the exponent. When I rewrite that, I end up with 8/7 times z to the fifth times d to the third power. And since z to the fifth and d to the third power are both positive exponents, they're going to be part of our numerator. So we're going to end up with 8z to the fifth d to the third over a denominator of 7. And this is number 23 on your worksheet, is 6g times 5g to the fourth power. Very first thing I'm going to do is I'm going to mark my g with an exponent of 1. Only because it makes it a little bit easier for me to see how to apply my products rule. So now I have 6g to the first power times 5g to the fourth power. I'm going to multiply 6 times 5. Those are my coefficients. 6 times 5 is 30. And then I have g to the 1 plus 4 power. And that equals 5. So the final simplified version of this is 30g to the fifth power. All right, work through the rest of the problems on your worksheet, and if you need any assistance, let me know.